Hi everyone, today we're going to be looking at wiring 3-wire DC, NPN, and PNP sensors. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in the series as well. So I was recently received a question on PNP and NPN sensors. They want an explanation on what a sync is and how to wire one. There's lots of confusion also over normally open and normally closed function of the sensor. Also, several diagrams will show resistors attached to blue wires and a load across the others. What does it all mean? Well, it's quite confusing sometimes, the language we use for these solid-state devices. Sometimes it is the way we talk about the sensor, and sometimes it's the devices we are connecting to that we talk about, which is sometimes is PLC. Now we'll try to break it down and go over the wiring to a PLC input. So let's get started. Up on my screen here, you will see I have my power supply here, and my power supply has a positive and a negative terminal, and that represents the plus voltage, and usually is 0 volts, which is represented by the negative. And electron flow or current that we put in the wire flows from your negative to your positive, and that's electron flow. However, conventional power flow or conventional current flow flows from positive to negative. So every time that we talk about the syncing and sourcing that we're going to talk about, we talk about the positive going to the negative, and that's why that arrow is showing through this circuit. It's going from the positive through the contacts here into the input of the PLC. Then the input of the PLC senses that input and then goes out the common back to there. So that means that anytime that we have the PLC as a common of 0 volts or minus, we tell that's a syncing input of the PLC. That means that this here, my input contact, is my sourcing because it provides the plus. So we always have the sourcing and then we have the syncing. So if we look at again the conventional current, and we have syncing provides a path to the common 0, and a sourcing provides a path to the supply. So in the first one here we have a syncing input, just like we did. So we have our common at 0, so that is my syncing, and my sourcing is my input itself. We can also have our sourcing input, so my common sits at plus voltage, and then my sensor here, or my input contact, sits at minus. So that means that this sensor is a syncing, and this means it's a sourcing input of my PLC. We can do the same thing for outputs of the relay itself, or output of the PLC. And again, if my common say is 0, this means that it's syncing output, or they sometimes refer to it as negative logic. And then we have here where my common sits at plus voltage, and that means it's a sourcing output, or positive logic. So the other thing we have is normally open and normally closed, and you probably hear this a lot of the times. A normally closed, or first of all, let's talk about open and close. When a circuit is closed, it means that it's allowed to let current flow through that section. So closed means flow. If we have something open, it means that current is not allowed to flow through. So it's always open, or it's open. So open and closed just means whether it's on or off. Now, normally open means that if no other apparatus is activating on it, or the sensor is not sensing anything, then that will be open, meaning you will not have current flow. A normally closed means that if nothing else acts upon it, then current is flowing, so we have the flow of current through there until something acts upon it and it opens it up. Now, an example of the normally closed would be your emergency stop signals into the PLC or into a controller, and that normally closed will open up when someone hits it. So everything functions normally. You have something hit it saying stop, and then it opens up that circuit. So that's totally different from our sensors themselves. Our sensors can be normally open or normally closed, and some sensors, like the one we're going to be wiring, actually will do both. It depends on how you want to set it up or program it. So let's take a look again at our input, and here we have our common sitting at 0, and it's going into 0 of the PLC, or the common point of the PLC, 0 volts. So that means this is a syncing input. So that means our sensor here is on plus voltage. So that means it's a sourcing input. And so if we look at the actual diagram, if we replace that sensor with a 3-wire sensor, now we have something like this. So it looks a little complicated. However, we can break it down. There's my syncing input that we just discussed. There's my common point, which is sitting at minus voltage. Then my outside of my common goes to my switching here. And then what we do is, if the transistor switches, it's switching it back up to 24 volt. So that means my sensor is a sourcing input. So let's look at our actual hardware that we have here. And here we have our click PLC, and we have our input point. And the first wire here is my my common, and then I have my second point down, which is my actual input. So my sensor that we're using right now is actually a CK1. It's a capacitive proximity sensor, but inductive proximity sensors work similar to this. And in this particular case, you can see here I have it wired. We have 3 wires coming off. We have a black wire, which is my switching wire, which would represent my output here, and that goes always to my input point of my PLC, which is X1. Then we have our blue wire, and the blue wire is always the negative supply, or 0 volts. So my blue wire is coming back and it's being connected to my minus 24, or my 0 volt DC, or negative. Then my brown wire is my power wire, and that power wire is connected back to my plus 24 volt DC. So currently right now, my common point is connected to my negative right here. So my common point, my negative, so that's my connection here. And you can see that if I take this proximity sensor, and it's really detecting the table that we have here. If I go up and down, you can see it turning on and off. So that is the wiring diagram for my sensor. So that would be my PNP, current sourcing field device. Now, the next one, if I look at this one, if I have my common sitting at plus voltage, and then we have a 0, or my negative part of my terminal, going to my sensor, and then my input, that means this is the sourcing input to the PLC, and my sensor is my syncing sensor. So again, this box here, we're going to replace with our diagram. So here you can see my common is connected to my plus 24 volt, and then my input is still my My output of my sensor is still connected to my input. That stays the same. And then my sensor goes back to 0. So that means that this is a syncing sensor and this is a sourcing input. So again, we take a look at our hardware here. And the first thing I'll do is unplug while I wire this. And this particular sensor I'm using can actually be NPN or PNP. So all I'm doing is I'm changing my common of my ground. Instead of being to my 0 volt DC, it's now to my plus voltage DC. So we'll plug that back in. And again, you see my light is on and my input's triggered, and I can make sure it's working by just lifting this up and it turns off. So in this particular case, you can see that my common is now sitting at my ground wire or my positive voltage. And then we go back to the switch and my switching is right here. So that means that here we go. We have our common sitting at plus voltage. Then we have our output of our input here to the PLC going back to the switch. The switch switches and it switches to the negative part or my 0 volt DC. So it's a syncing of the output. So if you enjoyed this video, please click the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time.